Okay, hello everyone. Welcome to my channel. And in this video, we are discussing about like the daily problem, like the problem of the day of GFG. That is the maximum number of 2 cross 2 squares. So it is an easy problem. So what we are given in this problem? So basically, we are given the base in units of a right angle isosceles triangle, and we have to find the maximum number of 2 cross 2 squares that can fit in the triangle with the like given base, right? So basically, we are given the base of the triangle, and basically we are given that it is the isosceles triangle. What is mean by isosceles? That the two sides of the triangle are equal, and like we have to find the maximum number of 2 cross 2 squares that can like fit in the triangle with the given base, right? Yeah. So like how do we approach this problem? So basically, it is a pretty much simple problem. It is a basically simple math. So see, basically, I first of all, I will take the example of this question, right? So if you see at this question, we are given like the base is of length 2, right? So how the base is of length 2? So basically, if I like suppose like see, this is of length 2 from C to F, and if I like draw perpendicular from I to like the base, so this portion is also of length 2, and suppose I like draw perpendicular from L to the base this, so like this portion from this to this is also 2, and from this portion to this portion, like from this portion to B is also 2, right? So like how we will how we approach this problem. So basically in this like problem we have to like go order wise, like from the reverse we have to start the traversal. Like how do we know like how do we approach the problem? So like you can see that like it is an isosceles triangle, so this side must be equal to this side, right? So if I take a small triangle, this triangle, so it is also a right angle triangle. So this side must be equal to EF, like CF must be equal to EF. It is an isosceles triangle, right? So basically we know that we have to find 2 cross 2 squares, right? And in a square all the sides like are equal, right? Means Km equals to Kl equals to Lj is equals to Mj, right? And HL is equals to 2, and HI is also equals to 2, and EI is also equals to, EF also equals to, right? And similarly CF is also equals to, because EF is equals to CF by isosceles property of a triangle, right? Right. So yeah, I hope this is visible. So what I'm trying to explain is that like we are given a triangle, and like we have to like calculate all the like 2 cross 2 like square that can be possible. So what we are going to do is that we will simply like just we have to like calculate like how many triangles like how many squares we can like it can accommodate, right? So like you can always like think of one thing, that like if we consider this whole like triangle, if I consider the lower part of this triangle, like this part, right? So this part should contain some squares, because if I have to like accommodate at least one square, then this lower part must have like it is the biggest part of the like triangle. It is the base, so it must accommodate some squares, right? So basically, if I see a triangle structure, we will notice that it cannot accommodate like its full area or its full volume cannot accommodate all the squares. There is always some portion like this triangle that always remains vacant, right? For this case is this, for this is there, and for this is there, and for this is there. I hope you like understand what I'm trying to explain, right? So there must be a part that is always like remains vacant here, right? So what I will do is that like I can think of one approach, like a common observation is that the part, like if I consider that part in the like in terms of the length of the base, right? So if I like consider like how many squares can accommodate in the like from the base, so I can like take into account the like length of the base, because like suppose my length of the base is like L. So I will just divide it by if I don't have a like suppose we have a like rectangle, right? So if I suppose a random situation, if I am given a base like base length of the rectangle, and I was asked to like calculate how many squares it can accommodate if there is no further like constraint. So I will just have an approach like I will just divide the length of the base with the length of the square, and this must like return the number of squares it can accommodate if my length is quite enough to accommodate these squares, right? So what I can do is that I am sure that it is not going to accommodate like all of its area. So there must some area like in the shape of rectangle that must be kept on like vacant, right? So what is the length, what is the base of the triangle that remains vacant all the times, right? So like you can see of one observation that this is a side of the square that must always be present at the end when there is some vacant space. In every example, you can see that there must be a side that must enclose the triangle, right? So this is of size 2 of course, right? And like you can also see that this is an isosceles triangle, so this side is equals to this side, so this is also equals to this side, right? EF. So as we know that this side length is 2, so this side length must be of length 2, right? So these sides lengths should be equal, right? So we will notice that there should always be a triangle that have a base length of 2 that remains vacant all the time, like in the every level. So in this level we have a triangle with base of length 2, right? In this we have a triangle with base of length 2, right? So right, in this we have a triangle with base of length 2, right? So what we are trying to do is that I will start from the like end, and suppose we are given a like base length of 8, right? So I am pretty much sure that all the volume is not covered by the square, so I will just first decrement it by 2. That like is that is of no significance for us, right? And after that the length that remains here is 6, right? The length that is required, right? So this length 6 will accommodate our squares, right? So if I divide it by 2, that is the length of the square. So I am getting that I can like have 3 squares, right? 3 square that can accommodate in the deepest level. So if I go moving on upwards, so I will just like look that as we go upwards there is a like length decrement of 2, right? At every time, because it is a square, we have to like it is a isosceles triangle, so this length must be equals to this. So there is a decrement of like the side of square at every level, right? So if I calculate the length of this area, like we have like equals to 8 minus 2, that is 6, right? This whole length is 6, right? Similar is the case we will do in this case in the second last deeper level. We will just do, we have a total length of 6. Yeah. So what I am trying to explain you that if I go to the second last steeper level, so my length becomes 6, and the like it is not, of course, the basically it is not the useful length. So I will just decrement by 6 by with the help of by 2, and I got my useful length to be 4, right? And I will just divide it by 2 here, and I will get my desired number of square, like how much can I accommodate the maximum square. Similar is the case when I move on to this this step, the third last level. I will just have the length that remains here is 6 minus 2, that is 4. This is the 4 length, and I will just decrement this 2 length from here, so it becomes 4 minus 2, that is equals to 2, and 2 divided by 2, this is 1 square that I can get here, right? So 1 square is there. So if I add all these squares, and there's a minimum of 1 square, right? So I can get a minimum of 1. So if I add all these, so I will get 3 plus 2 plus 1, that is equals to like 6 square. That is our answer. So you understand like how we approach this question, right? So you can understand one thing, like can you see a observer pattern like 6 upon 2, then 4 upon 2. We are like traversing from the deepest level. So 6 upon 2, then 4 by 2, and then if I move on to this level, this will be 2 by 2. So you are understanding any pattern, like how what we are doing. We are just like taking this this thing, and after at every level we are just decrementing 2 from this 2 from numerator, and divided by I am dividing with 2, right? And I am like adding the count of the squares by this value. And after that, like in the next level, what I am doing is that I am like decrementing 4 minus 2 in the numerator, and in the denominator is it is remain it will remain as 2. So you are observing a pattern that like we are having 6 by 2, then 4 by 2, and then here is 2 by 2. So don't you see like AP here, like you are seeing an AP, right? So you must be thinking like this must be a chance of game, like so don't worry, I will try to explain with you different example. So suppose I have 7, I have a 7, right? So yeah, if I have a 7, so what I will do, if I am a 7, suppose I have a 7. So you must be knowing that like the leftover part should always be 2 at every case, because there must be a square wall here. This must be equal to this. So the leftover is always 2, right? So what I will do is that like I will just like 7 minus 2 is the like useful length that I can get, right? So 5. So 5 is the like length that I can get. But I cannot make exactly number of squares because 5 is an odd number. So if I divide it by 2, I can make 2 squares from here. So it will become like 2 squares here. And in the above step, what I will do, I will just decrement 5 by 2, because there must be a place this here that I am not using. So 5 minus 2 upon 2 is the number of squares in the next level. And after that, in the next level there must be a case, right? So I will do like it will be 3, so 3 minus 2 by 2, that is equals to 0. As you can also see that I cannot make a proper square if you can get a you, it is a straight triangle, right? So what I can do that this is equals to, this is equals like 1, this is equals 0, so the sum is basically 3. So you are also observing a pattern here. It also 5 upon 2, like then 3 upon 2, then 1 upon 2. So it is an AP in the numerator with having a numerator is decreasing by 2 at every step, because you are given 2 cross 2 square, right? So if I divide it, so I can get here 2, then 1, and then 0. So like the whole, if I divide the numerator and denominator, it is also following an AP, right? So I hope you understand the approach. So let's see the code. I will explain that in the code pretty much well. So what I will do, yeah. So what I will do here is that what I will do that as you can see, what I have done is that yeah. Yeah, so in this code, what I have done is that I have taken a base by 2 minus 1. So basically, I am taking a variable n that is equals to basically base upon 2 minus 1. So what base upon 2 like minus 1 indicates, right? So base minus 2, let me show you what it indicates. So yeah, so base by 2, what is indicate? Suppose like we have an like 8, 8 in the like overall length that I am given. So if I like they see, if I like calculate the whole number of square that can be possible with the given length, so it will be 4. But I have already explained you that I cannot use all the available like length, so I have to like decrement 2 here firstly, right? So what I have done is that I am like just having base upon 2. Base upon 2 basically indicates like how many squares are possible if I don't have a triangle, if I have a like whole sheet like a rectangle. So base upon 2 is the maximum number of squares, but we know that there is a waste space that is of like length of that is equals to the length of the square. So I will just decrement by 1, because it adds on this square, but we can't have this square because we have a rectangle triangle. So I have only half the part, so I will not consider this. So I have like calculate the number of squares in the deepest level, that is equals to base upon 2 minus 1, these 3 squares, right? Like we have 8, 8 by 2 minus 1, that is 4 minus 1, that is 3. That is in the, like you can understand that the 8 is the length. 8 upon 2 base by 2, 4. 4 minus 1 is equals to 3. So like 8 upon 2 minus 1, right? 8 upon 2, that is 4 minus 1, 3, right? So like once I calculated the number of squares in the deepest level, after that what I can do is that I know that there is an AP when I move forward in the upward direction. So what I will do, I will just n into n plus 1 by 2, you know, the sum of the AP already been going in the previous classes. And after that, like you can return the answer you have gotten. So basically this is a pretty much simple code. I hope you understand this question. And basically this is a mathematical question. I hope you understand the question. If you like the question, do hit the like button and like subscribe to the channel and share among your friends, and I will see you in the next video. Bye bye. One second. Okay, so basically it is an accepted solution, as you can see. Okay, thank you.